In the midst of the gigantic show of the universe, we waver on the cusp of earth-breaking disclosures that obligate us to really impact our viewpoint on the universe. The presence of the James Webb Space Telescope fosters the extent of our superb assessment, reviewing further into the advantaged bits of knowledge of reality than any time anticipated. Leaving on this new pursuit through J's knowing, we offer an individual check, the unusual early universe. Out consequently, depict standard boundless standards as we experience into this illuminating area. The mosaic of our cognizance spreads out, revealing offbeat plans and covered intricacies that oblige us as we plunge significant into how James Webb just perceived monstrous plans that shouldn't exist. Could you anytime envision investigating a time machine, uncovering stories from age to work out insistently? The James Webb Space Telescope has done basically that. It's for the most part imperative significant field picture produced from a mosaic of 690-man outlines, depicting a fix of SK in the space of the giant scoop's handle, generally on various occasions more noteworthy than its ancestor. It's like holding in a massive interstellar jigsaw puzzle where each piece is a specific universe from the early universe. These photographs present a complex, tricky dance of systems, some of which existed just an enormous number of a critical time span after the tremendous impact. Their delicate shines are a quiet insistence to their distance and age, disclosed by the unrivaled infrared responsiveness of Joe's near-infrared camera. This observable a gigantic leap in bombastic assessment, surrendering astounding reconsider into the universe's nent stories. Up to now, maybe the best exposure before 100 extended lengths of it is that our home to zero in on the universe changes also makes with time. Not simply in minor, unimportant ways like stars moving about, gas hazes pressing, and enormous stars bombing pitiably in tragic influences. No, our entire universe has changed its essential person at least 2 or multiple times in the distant past, thoroughly changing its interior state at an overall boundless scale. Take, for example, reality that at one time in the overcast iller past, there were no stars. We know this essential reality in light of the way that of the presence of the vast microwave foundation, a shower of fragile but creative radiation that soaks the whole universe. Assuming you experience an inconsistent photon, a sprinkle of light, there's a decent open door. It's from the huge microwave foundation. That light takes up more than 99.99% of all the radiation in the universe. It's an extra from when the universe was only 270,000 years old and progressed from a hot, irritating plasma into a fair-minded soup with no positive or negative charge. Change conveyed white-hot radiation that all through the scope of 13.8 billion years chilled and reached out off into the microwaves, giving us the establishment light that we can recognize today. At the season of the presence of the cosmic microwave foundation, the universe was around 1/1,000,000th its ongoing volume and gigantic number of degrees. Truth be told, it was too fundamentally uniform to bubble it with density separates no more noticeable than one fragment in 100,000. So, not conclusively a state where stars could cheerfully exist. In the period following the transport of the cosmic microwave foundation, delicately known as WMX in space astronomy circles, the universe was in an odd state. There was a consistent shower of white-hot radiation, yet that radia piece was rapidly cooling as the universe went on with its steadfast expansion. There was faint expected outcome hanging out, despising its own business, and there was the, at this point, neutral gas, essentially hydrogen and helium, finally set freed from its fights with radiation and free to anyway. What it fulfilled to do was to invest energy with however much itself as anyone would imagine. Expectedly, fortunately, it didn't need to lock in the early universe. Little quantum hazards stretched out to turn out to be only contrasts in thickness, and why that happened is a story for one more day. These minuscule thickness contrasts didn't impact the more noteworthy cosmological expansion, yet they affected the presences of that fair hydrogen. Any fix that was to some degree denser than ordinary, even by a negligible little piece, had a to some degree more grounded gravitational draw on neighbors. Upgraded pull encouraged more gas to join the party, which expanded the gravitational power, which engaged considerably more neighbors. And so on, like brilliant music at a local party, going in much the same way in alarm tune to help more rares. All through an enormous number of years, the rich gas got more significant and the mournable gas got less fortunate. Through essential gravity, little thickness contrasts created, constructing the first enormous participant of issue and draining out their environments. Somewhere, Some part of impartial hydrogen got fortunate, keeping layers subsequent to overwhelming layers on itself. The most profound center came to an essential temperature and thickness, driving tangled structure, reaching off a nuclear mix, and changing over the harsh substance into helium. That savage cycle too conveyed a touch of energy, and in a burst, the chief star was brought into the world. Strangely, starting from the initial dozen minutes of the enormous blast. Nuclear reactions happened in our universe, new wellsprings of light specking the universe, flooding the once void voids with radiation. These new wellsprings of radiation re-energized the neutral hydrogen that filled the universe during the supposed epoch of reionization. Through gravity, greater and more unusual plans emerged, building a colossal, enormous weaving of universes. In the meantime, everything continued to fly isolated. The stargazer Edwin Hubble sorted out during the 1920s that the universe is expanding, and in the late 1990s, his namesake, the Hubble Space Telescope, tracked down evidence that the expansion is speeding up. Consider the universe a some portion of raisin bread. It starts as a mixture of flour, water, yeast, and raisins. When you solidify these decorations, the yeast begins breathing and the part begins to rise. The raisins inside it substitute for systems, expanding further isolated from one another. As the part fosters, the Hubble telescope saw that the piece is correct. Rising of all time quicker, the raisins are flying isolated at a rate that goes against their gravitational interest. This speed increase radiates an impression of being driven by the horrendous energy of room itself, speculated faint energy, which is would in general by the Greek letter lambda. Plug values for lambda, cold weak matter, ordinary matter, and radiation into the territories of Albert Einstein's in general hypothesis of relativity, and you get a model of how the universe encourages this lambda cold weak matter. One technique for testing this image is by looking at especially distant immense structures. Undefined from thinking back to the hidden not many 100 million years after the immense case that started it all, the universe was more straightforward than its progression, simpler to take apart against assumptions. At any rate, as an examiners utilized James Webb to dive into the underlying fragments of the universe, they found something that shouldn't exist. These amazing disclosures then, at that point, by then put the insightful neighborhood in an issue in that they should examine the very basics of what they are familiar cosmology explicitly. Practically following the Webb telescope completely turned on in July 2022, James W.G.'s astonishing infrared mindfulness revealed the weak gleams of universes, clearly from the far-off universe, that had shaped essentially various a broad time interval after the tremendous impact. Space experts had expected such accomplishment results to emerge significantly more relaxed, at any rate, more than speculated. There was an impact of information. Those early outcomes happened so rapidly considering the way that scientists utilized a savvy, straightforward course to check gigantic distances. Cosmologists, for the most part, stuck down unlimited course through logical Ly assessing redshift, a loosening up of a universe's light toward the red end of the electromagnetic reach as a result of the universe's improvement. This requires the appearance of social affair and investigating a boundless systems, come to a time-consuming and inconspicuous process known as spectroscopy. The James Webb Space Telescope's fire hose of revelation was genuinely controlled by cruder, quicker photometry-based strategies that generally utilize clear sequences in a structure magnificence to actually take a look at their red change. As such, while the photometric outcomes came thick and speedy the previous summer, the spectroscopic results have started streaming, however by an exceptionally limited edge. Out as of now, at any rate with spectra-based distances close by from something like 12 candidate, researchers are finding that most evaluations are matching the early photometric results. The most recent disseminated in Nature stargazing confirms prior distance measures for extra frameworks perceived by the Farad significant extragalactic outline, as shown by Emma Curtis Poole of the School of Hure in Britain, who drove the spectroscopic results, focus on we've been accepting that this will have the decision to do it inside the essential start generally couple of months of this telescope was just inconceivable of the four the most far away is united with the to some degree blundering named Gonzi. It has a redshift worth of 13.2, significance we are seeing the system as it appeared only 320 million years sometime later the colossal explosion. That high redshift makes Jade 0 the most far off at this point known in the universe, a record that the James Webb Space Telescope appears to be set to break once more. but one undeniably that highlights space experts are so the nuclear focuses together in an empowered. We at this point know for express we are attempting a period of the universe no human has at any guide looked at earlier toward its staggering, says Peter Van Destruction of Yale School. This galactic structure, he strangely notes, is essentially barely more settled from our viewpoint than the by and large time sharks have existed on Earth approximately 300 million years. As such, you go from nothing to these evident universes in the glimmer of an eye. However, not all high redshift competitor in respectable systems have been so fortunate, which highlights cosmologists' early consideration. In July, another diagram called the Interminable Movement Early Delivery Science Review drove by Felstein, regardless of what a likely universe at a redshift of 16.4 only 240 million years after the colossal blast coming to fruition. Spectroscopy has shown that settlement was off track as revealed in late March in research led by Pablo Arabel Legend. Furthermore, cosmologist at the National Science Establishment nor lab the world is everything thought of as a dusty joke. Organized at a redshift of 4.9 still amazing, but not at all shape or form record-breaking. 1.2 billion years after the monster impact raised levels of star progression are tried to have tangled early photometric assessment, as Colm Donan of the School of Edinburgh in Scotland, a co-author on the work, figures we can be without any problem diluted by contamination. A high redshift universe can be duplicated by a lower redshift endless system with various highlights. The likely gain news is that this specific universe gives of an impression of being an extraordinary case, Donna says. A similar overview had the decision to affirm that two other up-and-comer universes didn't have a similar issue. One of these is Mother Structure, which is seen at a redshift of 11.4 around 400 million years after the colossal blast. Now that such universes are being stated, their intelligible thoughts can be considerably more completely explored. These universes are minimal, a gigantic number of times more unassuming than the smooth way, yet some show up incredibly awesome and colossal and have high star for rates like that of our reality, which, for outlines, approximately one new star dependably, while the universes make an effort not to yet present issues for driving models of cosmology. They suggest immense upgrades began beforehand and continued incredibly quickly in the universe, which specialists had in advance anticipated started making universes ready and prepared age of 1 billion years after the enormous blast. We're seeing a move of epic astronomical frameworks quicker than we regularly thought in advance, says Fabio Puy of the Harvard-Smithsonian Place for Space Science. The seasons of a piece of these early structures are overviewed at simply an enormous number, a significant stretch of time. This could have ideas for enormous plans of faint matter known as crowns that scratched early universes, and for faint matter particles themselves, like Sandra Ticella of the School of Cambridge conveys one of the tremendous open requests is faint matter. The start of inestimable frameworks is a touchy test for different dull matter models. Some tricky and maybe model-busting early universe up-and-comer universes in reality remain. First among them might be a class of limitless structures perceived by abhorrent Labby of the Swindon School of Evolution in Australia and his accomplices. The gathering tracked down universes with billions of solar masses fundamentally unclear in weight to the smooth way from just an anticipated 750 million years after the colossal blast. These universes are tend to on various events more unmistakable than universes actually found in this period and are gotten into structures on different times more unassuming than the smooth way. They're little yet they're huge, says Labby, who says Joe is continuing to find comparable systems on a very basic level any place it essentially examines. Above, for the time being, the universes have, so to speak, canister concentrated by photometry with spectroscopic assessment.